So this is just talking about the different shells for the electron orbitals, right?
Okay. Initial to final, right?
It what?
Is it initial to final or final to initial?
It should be,
Initial to final.
because so if this is our nucleus right here, and then we have this orbital and this orbital right here, and we had an electron right here, and let's just say a photon hits this electron, and then all of a sudden this electron gets excited and it jumps up in energy state and it comes over here. It only releases energy when it comes back down to this. And so when it comes down, that's when it releases that energy again. And so it would be the excited state back to the ground state.
So emission is going from, okay.
So absorption comes when it absorbs energy and moves up, and then
Emission is when it goes down.
right, it emits that energy again to go to a more stable state.
And do they get bigger or do they get smaller as you go further out?
Right, so the N is equal to the orbital out from the nucleus. So this N is equal to 1, and this is to 2. And then we could just keep drawing them like that. So N is the shell.
So the two answers would be either N2 to N1 or N3 to N2. But I remember somebody showing me that it gets either bigger or smaller as you get further out.
Right. I think what you're getting to is the fact that the shells get closer and closer together as you get further away from the nucleus. Is that?
Yeah.
Okay, so yeah, so the biggest energy difference will be between the first couple shells.
So even though like N2 to N1 and then 3 to N2 are only one apart, N2 to N1 is going to be bigger because they're further apart.
Right, the energy released.
Mm-hmm.
So, yeah, that's good that you caught up onto that, because as you move further away from the nucleus, the shells, they still get further away, but from each other, that distance decreases. So.